Find the eigenvalues and corresponding eigenvectors of the given 3 by 3 matrix. Let us take this matrix as A. Let matrix A is -2, 2, -1, 2, 1, -2. Next we have -3, -6, 0. So we have been given 3 by 3 matrix. Now we want eigenvalues. For eigenvalues, we want characteristic equation. So characteristic equation CE of matrix A is A minus lambda I determinant must be equal to 0. This is the characteristic equation of matrix A. So this inside part A minus lambda I can be obtained directly from this matrix A by subtracting minus lambda from the principal diagonal elements. What are the principal diagonal elements? Here we have principal diagonal element is this 2, 1, 0. These three elements are principal diagonal elements. Subtract minus lambda from all of these elements. Then we have -2 minus lambda, 1 minus lambda, 0 minus lambda, and keep other elements as it is. 2 minus 3 in first row. In second row we have 2 minus 6 minus 1 minus 2. Here we have to find the determinant of this matrix. Now in first row we assign the signs. This is taken as positive, negative, positive. Now expanding from the first row, now take this -2 minus lambda into, take this first element, that is A11. Now after that apply AD minus BC to these four elements. See here we have this and this. So apply AD minus BC here, leaving the first row and first column. Leaving the first row and first column, we have this four element. Now apply AD minus BC, cross multiplication, that is 1 minus lambda into, we have 0 minus lambda will be minus lambda. Put the minus sign, then we have -2 into -6. Now write down the second element of first row, that is -2. Now leave the second row, leave the first row and the second column. Then we have four elements. We have these four elements. Now apply AD minus BC to these four elements. So we have two into minus lambda, put the minus sign, then we have -1 into -6. Next we have this third element of the first row, -3. Take big bracket, then leave the first row and the third column. We have four elements left. These are the four elements. Now apply AD minus BC here. This will be 2 into -2 put the minus sign, then we have minus 1 into 1 minus lambda, that equal to 0. Now here I have 2 minus lambda, then multiply this minus lambda to this, it will become minus lambda plus lambda square. Now here we have minus sign, minus into minus will be plus, 2 6 are 12. Here we have minus 2, this will become minus 2 lambda, minus 1 into 6 will be 6, minus 3, minus 4. Multiply this minus into minus will become plus. So here I have 1 minus lambda equal to 0. Now we have minus 2 minus lambda as it is. Here write down lambda square minus lambda minus 12 in order, highest to lowest. Then we have minus 2 into minus 2 lambda minus 6 minus 3. We have minus 4 plus 1 means minus 3 minus lambda equal to 0. Now multiply this minus 2 to this bracket term, we have minus 2 lambda square plus 2 lambda plus 24. Next multiply this minus lambda, then I have minus lambda cube plus lambda square plus 12 lambda plus 4 lambda plus 2 6 are 12 plus 3 into 3 is 9 plus 3 into lambda will be 3 lambda is equals to 0. Now here we have highest power is lambda cube, so we have minus lambda cube. Next we have lambda square, 2 lambda square are there, that is it will become minus lambda square. Next we have lambda terms, here I have lambda 12, 14 plus 4, 18 lambda, 18 plus 3, 21 plus 21 lambda. Next we have constant here 24 plus 12 will be 36 plus 9 45. We have plus 45 is equals to 0. Now here take minus common, that will become lambda cube plus lambda square minus 21 lambda minus 45 is equals to 0. Now this is a cubic equation having 3 roots. Now we have this cubic equation, it has 3 roots. Let us take the root of this cubic equation as minus 3. Let us substitute that. We have minus 3 cube plus minus 3 square minus 21 into 3 minus 41. So 3 cube will be minus 3 3s are 9, 9 3s are 27 plus 3 square 9. Here I have plus 63 minus 45. So we have 27, 45. This will become 72 minus 72. Here we have 63 and 9. This will also be 72. So plus 72 minus 72 will get cancelled. So I'll get 0 here. Hence we say that lambda equal to 3. Lambda equal to minus 3 is the root of cubic equation, that is characteristic equation. So we got one of the roots. The other 2 roots can be obtained by synthetic division. Let us find out the other 2 roots by synthetic division. Let us take lambda is equals to minus 3 here. Now write down the coefficient of characteristic equation. We have lambda cube coefficient is 1, lambda square coefficient is 1, lambda coefficient is minus 21, constant is minus 45. Now put 0 below this one. Now add these two. Here I have 1. Now multiply this 1 to this root minus 3, that will be minus 3 here. Now add these two, I'll get minus 2. Now minus 2 into 3, this 2 into this 3 will be 6. Now 21, add these two, I'll get 15 here, that is minus 15. Minus 15 into 3 will be plus 45. So I'll get 0 here. Now get quadratic equation from here. We have 1 lambda square minus 2 lambda minus 15 equal to 0. This is a quadratic equation. Let us factorize this. Lambda square, here we have 1 into 15, first and last product, that will be 15. 15 can be written as 5 3s are 15, and 5 minus 3 will give us 2. So here I'll write down minus 5 lambda plus 3 lambda minus 15 is equals to 0. Now take common from two terms. We have lambda common, we have lambda minus 5. Here take 3 common, we have lambda minus 5 is equals to 0. Since these two are common, take lambda minus 5 common, we have lambda plus 3 is equals to 0. Now equate this, I'll get lambda equal to 5 and lambda equal to minus 3. Hence we say that all the eigenvalues we got, eigenvalues are minus 3, and 5. These are the eigenvalues of the matrix A. We got the eigenvalues. Now we want the eigenvectors corresponding to this eigenvalues. So in order to get the eigenvectors, now we want eigenvectors. Eigenvectors. To get the eigenvectors, we consider the system. Consider the system of equation A minus lambda I matrix multiplied to the x vector equal to 0. Consider this as equation. Now we want here A minus lambda I. A minus lambda I can be directly obtained from this A matrix by subtracting minus lambda from the principal diagonal elements, only from here. These are the principal diagonal elements. From this we can get the value of A minus lambda I, that will be minus 2 minus lambda 2 minus 1 2 1 minus lambda minus 2 minus 3 minus 6 minus lambda into we have this vector x that can be taken as x1 x2 x3 or xyz, that equal to 0 0 0. Now take this as equation 1. This A minus lambda I can also be taken from this determinant also. Here this elements inside this elements represent A minus lambda I only. Now we want eigen vectors. eigen vectors corresponding to eigenvalue lambda equal to -3, right? We want eigenvector corresponding to eigenvalue lambda equal to -3. Here -3 is repeated twice. Now to get that, put this lambda equal to -3 in place of this lambda. So this will become -2, minus will become +3 to 1 minus lambda, minus will become plus, so this will become 3 -2 -3 -6 minus lambda means 3 into we have x1 x2 x3. Here I have 0 0 0. Now 3 minus 2 will be 1, 2 minus 1, 2, 4 minus 2, -3 -6 3. Now carefully observe this system of equation. See here we have this row 1, row 2, this one row 1, row 2 and row 3. First row, second row and third row. If I see row 2 will be double, that is twice of row 1, correct? 2 4 6. If I multiply 2 to the first row, I'll get second row. Similarly row 3, carefully observe third row is nothing but -1 of R1. If I multiply -1 to the first row, I'll get third row. So all these rows are similar or they have a common factor. For this kind of matrices, we reduce this matrix to echelon form. It means that we try to make the element here 0. What we want to make these two elements 0. See here, I want this element to be 0 and this element to be 0 by using this. So I'll perform those two operations here. I'll make these two elements 0. How? Let me do it. Now the operations that I'm going to perform, I'm trying to change R2 using R1. So we want to change R2. So write down R2 with the help of R1. Now see here we have 2. So multiply this to R1 here. Let me write down this clearly. We have 3 rows, right? Now this 2 is multiplied here, this will become 2R1 and this 1 is multiplied here, so 1R2. So 1R2 minus 2R1, and see here we have 1 and 2. These two elements are having same sign, so for same sign we put minus. So I'll take minus here. One more thing, third row, I'm changing third row using first row, right? Now when we see first row and third row, only difference is minus plus. So if I add these two, then I'll get 0. So these are the operations that I'm going to perform now. Now 1R2 means same R2, 2 4 minus 6. 2R1 means multiply 2 to the first row. So this will become 2, 2 2s are 4, 2 3s are minus 6. Now minus sign is there, so put minus, minus, plus. So I'll get here 0 0 0. So second row will become 0 0. Now R3, R3 is minus 1, minus 2, 3. R1 is 1 2 minus 3. So if I add this, I'll get 0 0 0. So what happened to this system of equation? We have 1 2 minus 3. New R2 is 0 0 0. New R3 is also 0 0 0. X1, X2, X3 is equals to 0 0 0. Now we have backward substitution here, that is multiplying these two matrices. 3 by 3 matrix is multiplied with 3 by 1 matrix, so I'll get 3 by 1 matrix. So first row with first column, so 1 into x1 will be 1x1, 2 into x2 will be 2x2, 3 into x3 will be minus 3x3 is equals to 0. So I have only one equation, x1 plus 2x2 plus 3x3 is equals to 0. Here we have only one equation, right? Only one equation, three unknowns. One equation and three unknowns. Three unknowns are x1, x2, x1, x2, x3. So one equation means I'll get one unknown only, so other two unknown can be supposed or assumed. Let us assume x2 value as some k1 and x3 value as some constant k2. So I'm taking x2 and x3 value as constant k1 k2. Now put this k1 k2 in equation, the above equation, that what will happen here? I'll get, let me write down here, x1 value will be 2 into x2. X2 is k1. Next we have minus 3 into x3. X3 value is k2 equal to 0. So this will become x1 equal to, I'll get minus 2k1 plus 3k2. So we got the eigen vectors here now, that is x1 value I got minus 2k1 plus 3k2. Similarly x2 value I took k1, so k1, this is x3 value I took as k2. Now I modify this x1 x2 x3. See here, I'll write down plus 0 k2 1 k1. Here I'll write 0 k1 plus k2. So this vectors can be written as, let me write down the capital X eigenvector. Eigenvector capital X is x1 x2 x3. Capital X comprises of three x1 unknowns, x1 x2 x3. Now the value of this x1 is minus 2 k1 plus 3 k2. Next we have 1 k1 plus 0 k2, 0 k1 plus 1 k2, putting the values of x1 x2 x3. Now this matrix can be splitted as, this matrix capital X is splitted as, see here, let me write down this, minus 2 k1 1 k1 0 k1. So I'm splitting the matrix 3k2, 0k2, 1k2. Now if I take k1 common, then we have -2, 1, 0. Take k2 common, we have 3, 0, 1. So we got the linear combination of two vectors. Here this -210 and 301, -210 and 301 are the eigen eigenvector for lambda equal to -3. Repeated roots. 3 is repeated twice. So we got two eigenvectors from single eigenvector. Here this vector is a linear combination of two vectors. So we got the two vectors, eigenvectors corresponding to lambda equal to -3. Now we want eigenvector corresponding to 5. We got the eigenvector for lambda equal to -3. Now we want the eigenvector corresponding to lambda equal to 5. Now put lambda equal to 5 in equation 1. Put this lambda value here. In place of lambda we put 5 here. So this equation will become -2 minus 5 will be -7. 1 minus 5 will be -4, -2. Next we have -3, -6, -5. Into we have x1, x2, x3 is equals to 0, 0, 0. Putting lambda equal to 5 in equation 1 give us this system of equation. Now we have the system of equation. Now see here, for this system of equation we have three rows here, R1, R2, R3. Now I reduce this system of equation to echelon form. So I'll make this element 0 and this element also 0 using the first element, that is row 1 element. So the operation that I'm going to perform is R2 changes to R2 using R1. Here, see here, the coefficient of this R1 and R2 are required. Now multiply these two to R1. So this will become 2R1 and here we have 7R2. What we are doing, we are cross multiplying this 2 to this R1 and 7 to this R2. So I'll get 2R1 and 7R2, right? So here I'll write down 7R2 and 2R1, right? Both are having elements -7 and -2 are having opposite sign. For opposite sign we put plus in between them. Now multiply 7 to this R2, it will become 7 into 2 will be 14, 7 into 4 will be -28. Now 7 into 6 will be -42. Next to R1, multiply 2 to R1, it will become -14, 4, -6. Now add these two, I'll get 0, -24, this will become -48. Now similarly, this is new R2. new R2, or even if I divide this R2 by minus 24, then this will become 0, 1, 2. Now we want third row as R3 changes to R3 with the help of R1. Now let us see the changes. See, here we have minus 1 here, so multiply this minus sign, minus 1 to R1, that is take R1 into R1. So here I have 1 R1 and 7, this 7 to R3, so this will become 7 R3, and this elements minus 7 minus 1 both are having minus sign, that is same sign. So for same sign I put minus in between them. So here I have 7 R3, 1 R1, put the minus sign. Now 7 R3 will be 7 into 1 will be minus 7, 7 2s are minus 14, 7 5s are 35. Now we have R1 minus R1. First write down R1 minus 7, 2 minus 3. Now multiply minus sign, this will become plus, minus, plus. So this will become 0, minus. Now minus 7 plus 7 will be 0, minus 14 minus 2 will be minus 16, and 35 minus 3 will be minus 32. Now we got new R3. If I divide this R3 by minus 16, then we have R3 as 0, 1, 2. So the given matrix will now become minus 7, 2, minus 3, and this will become 0, 1, 2, 0, 1, 2. x1, x2, x3 is equals to 0, 0, 0. Now again, if I subtract this R3 as R3 minus R2, so that this element, I want this element to be 0. So if I subtract, then I'll have minus 7, 2, minus 3, then I have 0, 1, 2, 0, 0, 0. These two rows R2 and R3 are same. Next we have x1, x2, x3 equal to 0, 0, 0. Now by backward substitution, I have only two equations. Here take x1, x2, x3. So this will become minus 7x1 plus 2x2 minus 3x3 equal to 0. Equation form from matrix form. Now second row, first row will become this, and second row will become 1x2 plus 2x3 is equals to 0. Now let us take the value of this x3 as some constant k1. So from this equation I'll get x2 will be 2, x3 values k1 equal to 0. So x2 will be minus 2 k1. Now from the first equation, minus 7x1 plus 2 into x2, x2 values minus 2 k1 minus 3, x3 values k1 equal to 0. We have minus 7x1 minus 4 k1 minus 3 k1 equal to 0. So minus x1 is equals to 4 plus 3 will be 7 and that side it will become plus 7k1. So minus 7 plus 7 will get cancelled. We have x1 is equals to minus k1. Now let us put this in vector. Eigen vector capital X is x1, x2, x3. So this will become x1 is minus k1, x2 is minus 2k1, this is k1. Now if I take k1 outside, or minus k1, or only k1 outside, then we have minus 1, minus 2, plus 1. So this, if the value of this k1 is taken as some 1, if k1 value is 1, then vector will be minus 1, minus 2, 1 will be the eigenvector for eigenvalue lambda equal to 5. This is the answer for this question. Now take again small submatrix of this 3 by 3 matrix, this one. Now take these elements minus 7, 2, 2, minus 4. Now apply AD minus BC here. So I'll get x1 upon 2 into 6 will be minus 12, minus 4 into 3, minus into minus will be plus, it will become 12. Next we have x2, apply AD minus BC here. 3 into 6 is minus 6, minus 6 sevens of 42. Then we have x3 is equals to, apply AD minus BC, 7 into 4 will be 28 minus 4. Now this will become x1 upon minus 24 is equals to x2 upon minus 48 is equals to x3 upon 24. Now cancel this with 24, 24 ones are, 24 twos are, 24 ones are. So we have x1 by minus 1, x2 by minus 2, x3 by 1. That must be equal to some constant k. So if I equate the denominators to k, I will get minus 1k, x2 equal to minus 2k, x3 is equals to 1k. So the eigenvector capital X will be x1, x2, x3 will be minus 1k, minus 2k, k. If I take k common, we have minus 1, minus 2, 1. If the value of this k is 1, if k is taken as some constant 1, then the value of this x will be minus 1, minus 2, 1. So this is the eigenvector corresponding to eigenvalue lambda equal to 5. This method is short.